Download this code from codegive.com, link in the description below. Apache's allowing coded slashes and backwards compatibility, a detailed tutorial. The Apache HTTP server, a widely used web server, strives for robust security and adherence to HTTP standards. However, legacy applications and systems might generate HTTP requests with malformed headers, specifically those containing encoded slashes, /. These malformed requests, while technically incorrect, might be necessary for compatibility with older clients or services. This tutorial will explore Apache's allowencodedslashes directive and its implications, focusing on enabling it for backwards compatibility while minimizing security risks. Understanding malformed headers and encoded slashes. HTTP headers should generally adhere to RFC 2616. This RFC specifies how headers should be formatted, and slashes/ are generally not allowed within header values unless properly escaped. However, some older applications or improperly configured clients might send headers with encoded slashes, like %2f. These encoded slashes, while representing a standard forward slash, are considered malformed by Apache's default configuration. The allowencodedslashes directive. Apache's allowencodedslashes directive, when enabled, tells the server to accept HTTP requests with encoded slashes within header values. This directive is crucial for accommodating older, non-compliant clients or applications that might rely on this behavior. It has two possible values. *No, default Apache rejects requests with encoded slashes in headers. This is the safer, standards compliant setting. *On Apache allows requests with encoded slashes in headers. This setting enables backwards compatibility but introduces a potential security vulnerability. Security implications of enabling allowing-coded slashes. Enabling allowing-coded slashes increases the risk of HTTP header injection attacks. Attackers might craft malicious requests with carefully crafted encoded slashes in headers, potentially bypassing security measures and gaining unauthorized access or causing other problems. For example, an attacker might inject malicious code into a referrer header. Best practices and mitigation strategies. While enabling allowing-coded slashes might be necessary for backwards compatibility, it shouldn't be done lightly. Always consider the risks and employ the following mitigation strategies. 1. Restrict the scope *. Apply allowing-coded slashes only to the specific virtual hosts or directories that require it. Avoid enabling it globally. 2. Input validation * Even with allowing-coded slashes enabled, rigorously validate all HTTP headers on the application level. Decode encoded slashes and check for unexpected characters or patterns. This is the most crucial step in mitigating the risks. 3. Regular security audits * Regularly audit your application and server configuration for vulnerabilities. 4. Upgrade clients * Ideally, upgrade or update any legacy clients generating malformed requests. This is the best long-term solution. 5. Web Application Firewall, WAF. Consider using a WAF to filter out potentially malicious requests. A WAF can provide an additional layer of protection against header injection attacks. Code example, Apache configuration. To enable allowing-coded slashes within a specific virtual host, edit your Apache configuration file, typically /etc/apache2/sites available /yoursite.conf or /etc/httpd/confd/yoursite.conf, depending on your system. Add the following lines within the virtual host block. This configuration enables allowing-coded slashes only for the /var/www/yourdomain.com directory. Requests to other parts of the server will still be subject to the default behavior, allowencodedslashes no. Remember to replace placeholders like yourdomain.com with your actual values. After making changes to your Apache configuration, restart the Apache service to apply the changes. For example, on Debian/Ubuntu systems. On CentOS/RHEL systems. Testing. After enabling allowencodedslashes, test your application thoroughly. Use tools like curl or browser developer tools to send requests with encoded slashes in headers and verify that your application handles them correctly and doesn't have vulnerabilities. Use a testing framework to generate requests with various types of malformed headers to improve the test coverage. Conclusion. Enabling allowencodedslashes is a trade-off between backwards compatibility and security. While it can be necessary for supporting legacy systems, it significantly increases the risk of security vulnerabilities. By carefully restricting its scope, implementing rigorous input validation on the application level, and using additional security measures like a WAF, you can minimize the risk while maintaining compatibility with older clients. Always prioritize upgrading legacy clients to eliminate the need for this configuration.